Welcome, guys. So this is our final physics GRE videos. We have final 10 questions, and after finish it, then we already solved 600. I already solved 600 physics subject GRE. So this is the final 10 questions. Okay, so 91. Basically, you have some object which has mass m and go down, and then somebody said that that button the speed is this. What is the rotation momentum of inertia? Okay, so this is very easy because we have the total translational energy plus rotation energy equals to the mgh, and omega just v over r squared. Okay, so we have this. So what we have is m plus I over r squared is this. So v squared is 2mgh divided by large m plus I over r squared, which is what? Which is 8gh divided by 7. So divided by h divided by g. What we have 14m is am plus a over I over r squared. So 6m a over I divided by r squared. So we get I is okay. So the answer is B. Okay. So 92 have two mass and equal mass. Consider somebody asks you about what? Hamiltonian, right? So all you need to know is Hamiltonian is kinetic energy plus potential. So which one is plus? B and D, right? B and D are plus. A, C, D are minus K, so which is definitely not okay. Okay, so answer must be momentum plus the potential. So there is a spring, right? So potential spring. The spring is half K times the L minus original L naught squared. So which one is the answer? E is the answer. Because you see this is half times plus K, so E is the answer. So this problem looks difficult, but all you need to just write down Hamiltonian, then everything is finished. Okay, so 93. Solution. What is this? Which of the following most possible value? Okay, so this is common sense. Your wave function your probability proportion to the wave function times the small volume, right? And then this volume is 4 pi r squared. So there's r squared term. So all we need to just times r squared on this wave function square, and then do a derivative on it, and then see which point. And see the solution for this. Seek for the solution for this. Okay, then nothing special. All we need to do is just do the computation. So basically, we are doing the r squared d over dr, r squared times. There are constant, right? But probably we don't care. So all we care is this minus 2r. So what we have is 2r this one plus r squared this one. This one is 0, right? So we can solve for the r. Get to do. So we get r is equals to a naught. Okay. So quickly, answer is C. Basically, I guess you can try to remember this answer because this question is I think it's very familiar. It's very common in the subject physics GRE. So 74, harmonic oscillator, and what it asks you about first order shift. Okay, so I suggest that. So I believe that you remember how to compute the first shift on usual grounds, usual n states. Basically, you just use this, just compute this. Okay, so we just compute this. Okay, and I think I don't have to compute. Okay, nice. I think I have to compute it because I guess probably you guys already forget about it. So this is v times n a dagger square n. So this is a plus a dagger square basically is a dagger a. And then if you have two a, then it will be n minus 2. And in the product n, so this turn is 0, this turn also 0. So this is all the remaining term. Okay, so this is also just the n a dagger a n, right? And then remember this. So sometimes I feel like the quantum mechanics just some stupid linear algebra. Basically, once you remember rules, then everything is very easy. Okay, so this is a dagger n, so it's square root n plus 1. So you get a. So you have square roots n plus 1, right? So you get a is square root. So this is n plus 1. Then I guess this is n. So you have 2n plus 1v. So n is 2. The answer is 5v. 5v. Okay, answer is E. Answer is E. Okay, so 95. Some electric field penetrate in. So, and ask about what? The magnetic electric field inside the material. Okay, so let me remind you guys. What is so the D is continuous, right? At the normal, right? So what? So D is continuous, right? So at the normal from left hand side is E naught, at the right hand side is what is E? Is epsilon E, right? So epsilon E, and epsilon is just K epsilon naught. This is epsilon naught. This is the D on the free space. This is in the dielectric. So basically, we just have epsilon naught E naught equals to epsilon E basically as epsilon naught K E naught. So cancel. What we get is this is E. So what we get is E just equals to KO epsilon E naught over K E naught over K. Okay, so let me write again. D n is continuous. So D is epsilon E plus P. Epsilon naught E plus P, or usually people just write it as epsilon naught E. So left hand side in the free space, you just have epsilon naught E naught, this, right? And the right hand side you have K epsilon naught E. This must be equal, so E is equals to epsilon naught divided by K. Okay, so the answer is A. The answer is A. So 66. A uniform charge of total Q is expanded from R1 to R2. And with the frequency F, and what is the power radiated by a sphere? Okay, so this is the difficult question, right? But you can see there is a symmetry, right? So symmetry uniformly. So the expand inward and outward and the same frequency. So basically the total radiation power is 0. The total radiation power is 0. So the answer is E. The answer is E. Okay, so 97, 97. You have this theta and the theta prime, and they ask you about if n is the function of lambda. Okay, so basically this is just the change of the Snell's law. Basically from the vacuum you have sin theta equals to n of lambda sin theta prime. Right, you have this. This is the Snell's law, and all you need to do is just do a differentiation from d lambda, so you get 0. You get d of d n d lambda sin theta prime times n lambda cosine theta prime d theta prime divided by d lambda. So you get the delta prime. What is delta prime? Delta theta prime. I think it's this one. Okay. Basically, it's okay. So this one is tangent theta prime. It's n of lambda minus tangent theta prime dn lambda over d lambda. So this one. Okay, and I take the absolute value. I take the absolute value, which what we get, right? We get is e. Oh, by the way, this delta prime basically is this one. So you should times delta lambda here. So what you get is this one. Okay, so you take absolute value and then you get the answer. Okay, so the answer is E. So 98. I think 98. I don't have to explain because you just weighted the energy on the Boltzmann. So the answer is the unit average energy of the system. The answer is A. Okay, 99. It's very good that we are coming to a final. The photon strikes the electron mass that is at rest, creating an electron positron pair. A photon is destroyed and the positron and the two electrons move over the equal speed along initial directions. Photons, the energy of photon was. Okay, I think this one is okay. So initial, let me write down the initial. Basically, you have the initial is PC times this. Right, this is your initial. You have the photon, right? Strike with mass and strikes an electron with mass. So this is the photon, right? Photon. This is the electron. This and finally, this is initial. This is final. The final, you have three objects, right? Three objects times, and three of them has the same. Three of them what has the same? You say what? Is that three of them has the same equal speed? And the positron and two electron have the same mass. So basically, the speed need to be, momentum need to be conservation. So any one of them should have P over 3C. So this is square. So and this is the momentum conservation. And the issue of one has the same electron mass square. So this is the total energy. And then you just then it equal, and you can solve it. Okay, so finally you can solve it. You get this one. Just square it and cancel some c squared term, and then finally you get the answer is D. So you get the PC equals to 4mc squares. Okay, so energy of so you want to find the PC because the P times C is the photon energy. Okay, so 100. Final question. This question is very long. I suggest that you read by yourself. Okay, so all you need to know is the change of the different light paths will correspond to different number of fridges. Will cause the fridges. Okay, so and the fridge shift occurs when d equals to lambda. So this is the standard results. Basically, you have so the change is 2d, right? Because you travel from d and go back. So the 2d will equals to m times lambda. And what we have is what? What we have the information is that we have 2d equals to m lambda. Okay, so we have 2d equals to m times lambda. So d is m lambda divided by 2. Okay, so d is m lambda divided by 2. Okay, so we have this one. So this is lambda, this is m. Oh, sorry for my whiteboard. Sometimes the whiteboard will crash. Okay, so we just use it. Then so this is for the red bin, red. And for the green, let's simulate the similar results. We get this. We get lambda just equals to 2d divided by m. So we have this divided by this. We get this. Okay, so we first use red equation to solve d, and we use d to get the green. This is for the red, and then we solve for the green because we first need to solve d, and then we plug d into this, and then we plug m, then we get the green. Okay, so this is the whole process of this, and basically you can read the equation by yourself, but basically the equation behind it is just the standard optics. Okay, so congratulations, and we have solved all of this. Then I will see you guys in the next other videos.